It's Ducati's best machine to date. But what are the special mechanics that give this bike the edge? To find out, Daily Planet turned its cameras on the meanest road test ever. Misano, Italy, race day. Superbike fans line the track for the qualifying session. All eyes will be on this man, Neil Hodgson. He's the sport's top rider.
And it's just really easy. Look at your lap time as you go over the line. Braking point, hit the apex, accelerate, and it's like you're a robot and you just do the same lap after lap after lap.
Sounds like just another day at the office. Only his office is on two wheels and it goes 300 kilometers an hour. Hodgson rides the all-new Ducati 999. It's the most highly engineered Ducati ever, and it shows.
He knows that his fastest time so far is that top one, 1:35.8.
Hodgson has qualified first. He's got pole position. His Spanish teammate, Ruben Zaus, also rides the 999. He'll likely give Neil a good run for his money. The Ducati team is ready to roll, but there's a big part of the team that's not at the track today. The engineers who designed the superbike work here.
On the CAD system, so computer aided design, you can check nearly everything, even in very preliminary phase. So when you start with prototype, you are nearly sure that everything is okay.
Andrea Ferraresi is the project engineer. His task was to build a fast, beautiful machine with improved aerodynamics and handling.
So don't worry, this is not a new color for our superbike. This material is called modeling clay, and our stylists use it to create a dummy, to check surfaces, to check their work.
Once the design is finalised, they build a prototype. This computerised milling machine has memorised every curve of the 999.
You can use this dummy for aesthetic purpose, but you can sit on it and check the ergonomics, for example.
They also check every new part, like this exhaust pipe. It has to exactly match the original design specifications. Finally, the entire engine is tested in a virtual race.
This is a so-called dynamic engine test bench in which we can simulate, and we are simulating now one lap, or more than one lap of course, on the Monza racetrack.
Inside a vented chamber, the throttle valves flip. The gears rev, but the bike doesn't move. It's like strapping a real engine onto a video game.
We can simulate the changing gear, braking condition, all the conditions that we have on a real racetrack.
Lights red, ready for a start, and we're away.
And speaking of real racetracks, Neil Hodgson is off to a good start. He knows the new bike has a lot to do with his success.
There's more protection on the rider, basically. The old bike, on the straights, you felt the wind more. On this bike, I feel very little wind.
On this kind of bike, of course, at 200 km/h on the racetrack, well, aerodynamic force are very, very high.
That's because aerodynamic forces increase exponentially with speed. When a rider doubles his speed from 100 to 200, the wind drag increases 4 times. So Ducati engineers really wanted to reduce the drag.
The flow that's come inside this intake, we try to kill, let's say, this strong side vortex that create drag and that impact on your shoulder.
Zaus for sure will just pull to the 999 lane.
Improved aerodynamics make the bike faster on the straights, something Ruben Zaus is taking advantage of today. He's caught up to Hodgson, but races are won in the corners.
It's all about balance. I think it's all about the laws of physics as well. It's not about going fast on the straight, it's about going fast round corners.
What the laws of physics say about high-speed cornering is one of the oddest but most important factors for riders and engineers alike.
If you have to make a turn in this direction, first you don't have to steer in this direction, but opposite, slightly.
No, he's not making this up. It's true. To turn right, you start by turning left. That causes the bike to tilt over on its right side. And that introduces something called gyroscopic force. You can demonstrate it with a spinning wheel and a swivel chair. As he tilts the wheel to the right, look what happens to the chair. Gyroscopic force pushes it in the same direction. And that's exactly what happens on the track.
So, due to gyroscopic effect of the front wheel, bike start tilting in this way. Meanwhile, bike is tilting, the steers start to follow you in this direction.
So tilting or leaning the bike actually pushes it around a corner.
The more corner speed you want to carry, the more you have to lean. But there is an optimum angle. If you lean any more, you lean off the edge of the tyre and then you crash.
The engineers can't help Hodgson find the perfect angle.
In the middle of the long corner, just have that little bit more turn.
That's something he just has to feel. But what they have given him is a bike that changes angles more quickly. The key is a new lower seat height.
We have lowered the seat of 50 millimeters, so this is the part that has been changed. It is important because now the rider is seated closer to the center of gravity, and so the bike is more flickable.
For a flickable bike, it means that they can lean it over to get through, let's say, the right corner of the chicane, but then immediately, as soon as possible, shift the weight back over by moving their body and get that bike up and over so it can go through the left part of the chicane.
With the new 999, you sit more in the bike than the 998. You're perched more on top of it. And the theory behind it is the low centre of gravity.
On the last lap of the race, the theory is working for Neil Hodgson. He still leads. But the science of the new superbike is working for someone else too. Teammate Ruben Zaus.
Side by side, can he get through? Hodgson tries to fight back, he can't do it. Zaus just carries the speed down the outside. Zaus, Hodgson, it's going to be Ruben Zaus, takes the double and beats Neil Hodgson. You couldn't have got money on that.
It's a tough loss for Hodgson. But a 1-2 Ducati finish is a big victory for everyone who helped create the 999.